Okay. So just like how we had these shortcuts for triangle congruencies, hey, you guys remember how we proved triangles similar and we needed like all the corresponding angles congruent and all the corresponding sides proportional? Okay. Hey, guess what? We have shortcuts for that too. So that's good. So we'll talk about those. We'll start talking about those today, and we'll finish talking about them tomorrow. Okay. So we have 5 different triangle congruencies. We're gonna first kind of recap those. Hey, what's the S stand for in each of these? Awesome. What's the A stand for? Angle. Okay. Side, angle, side, angle, side, angle, side, 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 angle, angle, side, hypotenuse, leg. Hypotenuse, leg only exists in what kind of triangle? Right triangle. Very good. Right, that is right. Anyway, what else is a knee slapper? A hand. Credit to Aubrey and that desk. So, happy now. Okay. Hey, so what do we notice about this side angle side? Where's the angle at? In the middle. In the middle. It has to be included between those two sides. Between those two sides, right? You guys remember that? Okay. Hey, what were our 2 triangle congruencies that don't work? We had 2 of them that don't work.
SSA.
Okay, very good.
A. O.
Okay, so side angle does not work. Remember, if you rearrange this one, you get a bad word. That's not why it doesn't work. It just doesn't work anyway, though, mathematically. But it's quite convenient for math teachers everywhere, I'll tell you what. Because I don't even want to imagine the trouble I'd have as a math teacher of a bunch of freshmen and sophomores seeing this word and having it as an option. Because, oh my gosh, you guys are ridiculous. So, and then also angle doesn't work. You need to have at least one side. That's accurate. So, more accurate than Cody Parkey of the Bears. So anyway.
That's
like that.
It was
wrong.
It was wrong.
I don't get it.
He's the Bears favorite.
Like if you would have made it was lateral. Like you missed the game.
So,
But it got nicked.
yeah, I got nicked. So now we are proving that triangles are similar. Hey, congruent, we had the symbol where it was like equal sign with a tilde on top of it, so it was like equal. Similar, what was our symbol for that? Does anybody remember?
It was just squiggly line.
Just the tilde.
Yeah, don't forget tilde. You know why?
Yeah, Kaylee, don't
Get it.
tilde.
You know why?
Well, I mean, it's been a year since we.
New year, new amazing tildes. Hey,
Yeah.
it's not.
Well, you haven't remembered your tilde last year, so.
Triple-sided. I think there's a thing there.
Okay, so angle similarity is the first one we're going to talk about. If we have these 2 triangles, and we're trying to prove them, we have these 2 triangles we're trying to prove similar. Our first one we're going to talk about is angle similarity. So, somebody give me a pair of corresponding angles in here. Noah. Awesome. Angle A and angle D. We would need these angles to be congruent. Because in similar triangles, corresponding angles have to be congruent. So if we say, hey, angle A is congruent to angle D, we're just going to go ahead and suppose that. Somebody give me another pair of corresponding angles here. Evan.
Angle C and angle F.
Okay, angle C and angle F. So if they're congruent as well, okay, if we know these 2 pairs of angles are congruent, 2 pairs of corresponding angles are congruent, then we can prove that these triangles are similar. You guys remember in similarity statements or congruent statements, we had the order mattered? Same thing, the order matters. So because this triangle goes A, B, C, this triangle has to go D, E, F. A is first, and it corresponds with D, so that's first. B is second, corresponds with E, so that's second. C is third, corresponds with F, so that is third. Now, this is really just saying that we can have any 2 pairs of angles. For angle similarity. You can have any 2 pairs of angles. So we happen to choose these because that's what Noah and the Pancreas Killer gave me. That's the only reason. Could have been any 2 pairs, but that's what was given to me, so that's what I accepted. But any 2 pairs of angles could have worked here as long as they were corresponding. Now you might be wondering, hey, Mr. Gossel, why is this not angle-angle similarity? We have 3 sets of angles. Why do we only need 2 sets? Well, good math students, thanks for asking. So the reason that is because if we know these 2 pairs of angles are congruent, what do we automatically know about the 3rd pair of angles? They're automatically congruent. There's no option but for them to be congruent. And so if you have 2 sets of angles congruent, you know 3 sets of angles are congruent. And we just take, say, hey, if we're going to make this a shortcut, let's make it a real shortcut and even take it away from A to just be AA. A. So, questions on that one, on angle-angle similarity. We're going to work on using them later, but questions on kind of the idea and concept. Okay, it's very similar to our triangle congruency shortcut, so which is good, it can kind of lend to that. So, side similarity. Hey, what do you think we're going to be using here? Sides. What? No way. Okay, so we're going to need these sides to be proportional. Somebody give me a pair of corresponding sides. Okay, Aubrey. Okay, side CA and side FD. Now you might be wondering, hey, Mr. Kossel, why did you write it as a fraction? Well, awesome math students, the reason I wrote it as a fraction is if we go back to our warm-up when we had similar triangles here, we took AB, which had a length of 8, over DE, which had a length of 24, and made that our ratio into a proportion. So that's what we're doing here exactly, is we're taking CA and putting it over FD. Josie, question on that in the next one? Right. Questions on that and why that's ordered the way it is. Okay, Josie, give me the next pair. Okay, side AB over side DE. And once again, Josie did a good job of following the pattern Aubrey said of doing small triangle over big triangle, and continue to do small triangle over big triangle with corresponding sides. Awesome work. Okay, Ian, I know you don't have your hand raised, but I'm pretending it is. So what's our 3rd pair of corresponding sides?
CB and FD.
Awesome. CB and FE would be the 2 sides. So if all 3 of these ratios are equal, we take the length of this CA divided by the length of FD. That'll be equal to our side AB divided by side DE, which will be equal to side CB divided by side FE. If all of those are true, then we know these 2 triangles are similar. So here, we need all the ratios to be equal. That's our big thing. We need all the ratios to be equal. Questions on that? Side angle side similarity. Side angle side similarity. So we need 2 sides and how many angles? 1. And where is this angle going to be? In the middle. It's the included angle, right? So let's take 2 sides. Instead of making you guys actually say out the sides again, we already did that, right? We already said the sides earlier, side. So I'm just going to write the first 2. Side CA over side FD will be equal to side AB over side DE. Now, if we're dealing with sides CA and AB, and sides FD and sides DE, what's the interior angle of those? Angle A and angle D. So those are the 2 angles that we need to be congruent for this to work. So, if this is all true, then these triangles will be similar, using side angle side similarity. So what we need for this one's a lot heads up. You guys have more room in the margins than I do. So you need 2 side ratios equal, and I'm going to write it in all caps and underline it because it's important. That's and. The included angles congruent. That's what we need for that one. We need all of that to be true. Also, Tyler Faith, feel free to pick out your own skills. there too. Yeah.
What did we get on this class? I don't know.
220.
No, I got official numbers.
It's
Oh,
220.
that's nice.
Nope, it's 220.
14. Hey, so
That means like
Quick math.
now when we prove similarity, we need the angles to be. Let's see what's right now. We need it. Did you sneeze?
No. I was making a cracking noise.
Oh.
Well, in advance, if you sneeze, you've already been blessed.
So the reason now I have to go. So the angles have to be what when we prove similarity? Congruent, which means their measures are equal. So just like in proving triangles congruent, we need the angles to be congruent. Now when we prove triangles congruent, we need the sides to be congruent. When we prove triangles similar, we need the sides to be
Equal.
they're not necessarily the same, proportional.
Oh, wow. We just got roasted.
You said that so happily.
He's honestly
You're
proud of
what?
that.
Good stroke.
Not supposed to what? You're not supposed to what? Oh, I'm not supposed to be learning today. Mr. Carlson, nice to meet you. Sorry.
Oh my gosh, I didn't even realize I was saying it. It's really what? It's a nice. I love it.
Now, what would happen if the corresponding angles are congruent and the corresponding sides are congruent? What happens? Then the triangles are congruent. Okay? If the corresponding angles are congruent and the corresponding sides are congruent, then the triangles are congruent. Now, are congruent triangles also similar? Are congruent triangles also similar? Yeah, they are. Yeah. It's a very technical thing, but they are. It just has a scale factor of 1. That's something we briefly talked about last chapter. Okay. Questions on this? Liddy. Hey, let's look at these examples down at the bottom. We're going to put these into practice. We're going to try using them, okay? So, do we have enough in this top left picture to prove that these triangles are similar right now? I disagree. I don't think we have enough at this moment. I think we can get there.
We are wrong.
Wait a second.
We have 5 seconds. Wait, no.
Yeah, we do.
No, we don't. Back.
They share an angle.
They share an angle. What angle do they share, Evan?
L and M are the same.
Okay, L and M are congruent. Now, are there any similarities that are just one angle?
No, you have to
Angle.
add up. I mean,
Oh,
JK
sorry.
and QP would be the same side.
Okay, do we know that JK and QP are similar or proportional?
No.
Something else? Do we know any side lengths right now?
No.
We need that to know our SAS or side. Okay. Ian, what are you thinking?
Well, we, since you know 75 is like for P and you know 48 is for J, so you can if you add them up, 57 plus 48, then they all add up to 180, so it'd be 75. Wow.
So Ian's saying, hey, all the interior angles of a triangle add up to 180. We know 2 of them. Can find the third. We add them up, subtraction 180. 58 or 57 plus 48 is 105. Get away from 180. That's 75. Does this angle match up with this angle?
Yeah.
So they are congruent. Now, do we have enough to prove it?
Yeah.
Okay. So you guys remember when we did congruent statements? We said like triangle something something something, or triangle something 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 by this. So we do the same thing but with similarity. So, Owen, did we name the first triangle somehow? Perfect. Okay. Now, what's the second triangle have to be if this one's JOK? It would be QMP. It has to correspond. J corresponds with Q, so they're both first. L corresponds with M, L second, so M second. K corresponds with P, case corresponds with P, K is third, P is third. And what shortcut did we use to get here? Angle similarity. That's not the shortcut, those are the mathematical. But angle similarity is how we prove they're similar. You guys kind of remember doing this with congruencies? We're just doing similarity analysis. Well, we did. So this would be our answer,
Wait, there's only
and the
one
stuff
scribble.
above would be our work.
There's only one scribble. No.
Okay. Question on this first one? Any questions on this first one? Yeah, stop it.
She's actually just crying.
I'm sorry, I'm trying. Mr. Carlson, nice to meet you.
This is why she cries. This is why crying.
Hey, so how about that national championship game last night?
I do love me a good butt kicking.
Man, especially when it's Alabama. That made me happy. That's a win for America right there, okay? Alabama getting
Everyone
whooped.
except for Alabama.
No, everyone wins. America wins when Alabama loses, especially when he's blown out.
Mr. Fossil, if you look at it, Notre Dame is better against Clemson than Alabama.
I'm like, hey, Trevor.
Alabama
You're the big yell. Hey guys, let's go on to the next one. Just kidding.
I was like, you're kidding, right?
No.
Why do you have a blanket?
Aubrey.
I started a board on Pinterest. Well, I was bored within a board on Pinterest. That's a bunch of dad jokes.